get rid of your square root in the bottom if possible. Okay? So, the first ones are pretty easy. Okay? If I give you the cubic root of 54 minus the cubic root of 2, you can add and subtract roots if what's underneath the value is the same. So you treat your roots as if they were variables. If they have the same value underneath that root, you can combine the coefficients. If they don't have the same value under the roots, then you can't add or subtract them. Does that make sense? Okay. But you want to first decide if your root can be simplified. Okay. So for example, in 54, that is the product of 27 and 2. And if you remember, your perfect cubes are 1, 8, 27, 64, and 125 are the first 5 perfect cubes. Okay. So what is the cubic root of 27? 3. So this is 3 and the cubic root of 2 minus the cubic root of 2. So if your values under the roots are the same, we combine our coefficients. What is 3 minus 1? 2 and the cubic root of 2. Okay. If I gave you 3a minus 1a, what would you tell me the answer is? 2a. You look at your roots as if they were your variable. There's an understood 1 right here. Well, what is the cubic root of 27? There you go. Well, because isn't that 2 left underneath your cubic root? There. So it stays underneath there. Because can I subtract a minus z? They're not like terms. It's the way we define that term, by what's under that root. Okay? Okay. Can we move on? Yes. Yes, it has to be cubic and cubic, square and square, and the values underneath have to be identical. All right. So this is the cubic root of 250 divided by the cubic root of 2. Are they both cubic roots? Yes. So I can, if you remember, if they're all if they both have cubic roots, I can write it as one fraction under the cubic root, correct? That's 250 over 2. Can I divide the 2 into the 250 then? Okay. So that's the cubic root of, and what is the cubic root of 125? 5. So multiplying and dividing has different rules than adding and subtracting. Adding and subtracting, what's underneath those roots have to be identical. But multiplying and dividing, as long as the roots are the same, we can perform the operation. Okay? All right. X, this is one term, 3x y to the 1/4. This is another term, 8x y to the 1/4. I'm adding and subtracting. So my powers have to be the same. Are those terms like terms? Yes. So what am I going to do? Combine what? 3 from 8, which is -5. And what do I do then? What variables are going to be attached to that answer? X, y to the 1/4. So when we're combining like terms, remember those variables are just going to stay the same. Just like those cubic roots are just going to stay the same. They get tacked on to the end of your coefficient. Okay. No, it's x to the first and y to the 1/4. Katie, does that make sense? Okay. Because if I have 3a minus 2a, are you just telling me that that's 1? Or is it 1a? It's how it's like what we're naming that term. And the name doesn't disappear. Okay. These are all under the fifth root. Would you agree? So this is going to be, what is the fifth root of x to the 10th going to simplify down to? X to the second. And okay, hold on. And what is the fifth root of y to the fifth going to be? Y to the first. Okay, why is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Isn't that what x to the 10th equals? Right? And if I'm asking for the fifth root, I need it in groups of how many? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. How many groups of fives do I have? 2. Because I don't have a coefficient, I have an exponent. If I wanted 2x, then I would have had to have 32x to the 10th. So that I would take the fifth root of 32 and the fifth root of x to the 10th. I'm only going to have a coefficient, Ellen, if there's a coefficient originally in the problem. Okay? And likewise, if I have 1, 2, 3, 4, 5, I only have one group, which is why the exponent is a 1 on my y. All right, well, let's think of an easier way to do this one. Couldn't I have said that this is x to the 10 fifths and y to the 5 fifths? Right? Because your root is your denominator on your exponent, right? What's 10 divided by 5? And what's 5 divided by 5? So we got the same answer. Comes out evenly. Okay? It's kind of a quick way to check yourself. All right, we have 6x y to the 3/4, 3x to the 1/4, y to the 1/4. Did your lines disappear on yours? No? Okay. Uh-huh. 1/4. Okay, so we're trying to reduce, and so we need to know our power rules, correct? So how do 6 and 3 reduce? I get a 2 in the numerator or the denominator. Okay. What am I going to do with my x's here? I have an x to the first and an x to the 1/4. I'm going to subtract. X to the 1 minus 1/4 is x to the what? 3/4. So it stays up on top because it's positive. Correct? Are you following this? Then on my y's. Y to the 3/4 minus 1/4 is going to be y to the 2/4, which is 1/2. And it stays on top also. Nothing's on the bottom, exactly. If any answer had turned out negative, Rachel, we would have dropped it down below, correct? Okay. All right, this one's the tricky one, and this is the one where you need to kind of see and recognize in your homework. This is a rationalization problem because I cannot pull anything out of my x. I don't have multiples of 3 x's, do I? Because it's just an x to the first. And I don't have an even number of y's because I have y to the 8th. What would I have to go to next to get a multiple of 3 for my y's? 9. Okay, I need a y to the 9th, and I can pull everything out, correct? Okay. I need to think about that because what I need to do to this problem is rationalize it. Okay, if I multiply the top of my fraction and the bottom of my fraction by the exact same value, I'm multiplying by 1. Would you agree? Okay, right? If I multiply by x over x, isn't that 1? Or 2 over 2, that's by 1. So we're going to extend out because under the cubic root, I want to multiply by whatever I'm missing so that I get a multiple of 3 on my y. Now you just told me I needed y to the 9th, correct? So how many y's are missing down below? a y. So if I multiply the bottom by a y, then I have to multiply the top by a y. So that means now I have the cubic root of xy over y to the 9th. Can I take the cubic root of y to the 9th? What is the cubic root of y to the 9th? Y to the 3rd. See how I don't have it under the cubic root anymore?
Wait, no.
Cubic root of y to the 9th. It's y to the 3rd. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many groups of 3's do I have? 1, 2, 3. It's like 9 divided by 3. Okay. So, but in the numerator, do I have any x's or y's that I can pull out? Do any of them appear 3 times or more? So then in the top, I leave the x and the y under the cubic root. It's simplest form because my variables, while they appear twice, one is outside a root, but the other is inside, right? And I don't have a root in my denominator, so I have now rationalized it. Okay? So if I give it to you in fraction form, like the previous one, you can work with them in fractions. Okay? If I give it to you in root form, like this one, you might have to rationalize it.
Oh, so like, are you saying?
See how my exponents were given to me in fraction form? I can just simplify using my rules for exponents. This one I was presented to you as a root. So you're going to want to think about how you're going to rationalize that. Okay. So this problem here is a lot like this first problem. Okay? The only difference is this has variables and numbers, right? And the first one just had numbers. But if we're going to combine our like terms, what's underneath the root needs to be identical. So we need to approach it by saying, can I simplify this out any further? Okay? So I'm asking for the 4th root of 2x to the 6th. I can't take the 2 out, correct? Because whatever I have has to appear how many times? Under my root? 4 times. How many x's are under my root? 6. Is there a group of 4 that I can pull out? There's one group. And under the 4th root, that 2 stays there, but how many x's are left? 2. Is this making sense? Okay. Because the x, I took out one set of 4 x's, and that's where it goes. Right? Because if I have a group of 4, I can pull that variable out. Okay? But I'm left with 2 more still underneath there.
Okay, I think what's confusing is that little 4 looks like it's an exponent to y instead.
Yeah, so you got to be careful. It is the 4th root. That's why I try and put it in that little corner. All right, minus 6. All right, 512. That's 2 times what? 2, 5, 6, which is 2 times 1, 2, 8, which is 2 times 64, right? Okay, which is 2 times 32, 2 times 16, 2 times 8, 2 times 4, 2 times 2. Follow that big loop? There's 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. I need them in groups of how many? 4. How many groups are there in there? 2 groups. I'm going to take 1 out, and I'm going to take another one out. Now, you told me there were 9, so technically, how many did we just take out? 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So what's left under my root? This little 2 right there. Right? That's still left underneath your root. So I'm going to say minus, we're going to say 6 times 2 times 2, which is 24. Would you agree? And under the 4th root, I know I've got that 2 sticking there. All right, can I take any x's out? Because I only have 2 and I need how many? 4. So that stays there, squared. Can a y come out? How many y's? 1. All right, now look. Is this term identical to this one? Are all the variables placed in the same places? There's an extra x sitting out in this one in front that's missing in this one, correct? Are they like terms? No. Therefore, this is my answer. I can't simplify it any further. Haley, you're going to be wishing you'd stayed awake. Okay? This is a pretty hard lesson. Okay, write the expression using positive rational exponents with no radical signs. All right. So this is 27, a to the negative 1, b to the second. And what's my exponent on this problem? What's the full exponent? 4/6. Exponent root. Okay, and 4/6 is also known as 2/3, right? So this is, sure, I'm just going to write it here though. All right, so what's your rule for raising a power to a power? All right, so that's 27 to the 2/3, a to the negative 2/3, b to the 2/3 times 2/1, 4/3. Numerator times numerator, denominator times denominator. What is, now, can we simplify 27 to the 2/3? Because it's, without your calculator. What's the cubic root of 27? 3 squared? Okay, so this is 9. Where's this? Huh? Because the cubic root of 27 is 3, and then I got to square it because I've got a numerator. Did you follow that, Rachel? Okay. If I have a numerator of other than 1, yeah, I'll take the cubic root or the square root, and then I'll square it or cube it, whatever my exponent, my numerator says. For the numbers, I think, yeah, probably most of them will be okay. Yeah. Okay, so then the b to the 4/3 stays here, and the a to the 2/3 drops down. Because the directions say write the expression using positive exponents and no radical signs, which is what we just did. All right. So, cubic root of x is x to the what? 1/3. The 6th root of x is x to the... Now, if I want to divide by the 5th root of x, does that go in the numerator or the denominator? And it's x to the 1/5. Are our bases the same in this problem? Are the bases all the same? They're all what? X. So what am I going to do with my exponents now? I'm going to add which ones? 1/3 plus, and then what am I going to do with the 1/5? Minus the 1/5. So you can do that on your calculator. Because our rules say if they're in the numerator, we add our exponents, and if they're in the denominator, we're going to subtract that exponent. Uh-huh. Uh-huh. Well, this is going to be x to the 3/6. Who gave me 2/9? Common denominators when you add your fractions. So 1/3 and 1/6 is 3/6. And 3/6 minus 1/5 will be 3/10. Really? Yeah. Well, you need to know that. You need to know your rules for exponents. If they're both on the same level, what would you do with an x squared times an x to the third? How many x's are there, Meg? So you need to know that. Okay? All right, here we go. What do you think I'm going to do in this problem? Yep, this because 1/3 plus 1/6 minus 1/5 is 3/10. Because don't I have this fraction down here? And don't I subtract that exponent then? Okay, so we distribute. We distribute the 3x to the negative 1/3 to the first term and to the second. So that's 3x to the negative 1/3 x to the minus 3x to the negative 1/3, 4x to the 4/3. First term, do you see that we have two terms? Okay. What am I going to get on the exponent for my x in my first term? This times this. This times this. Well, hold on. What is my exponent on my x going to be? What do we do with these values? What is negative 1/3 plus 1/3? Not 1, 0. Yes. Okay. What am I going to do with this 3 and this 4? Hold on. What am I going to do with the 3 and the 4? Multiply them. What am I going to do with the negative 1/3 and the positive 4/3? Add them. What do I get? 3/3, right? Which is also known as 1. So it's 3 minus 12x. So it's 3x to the negative 1/3, x to the positive 1/3. Because that's what I have here. 3x to the negative 1/3 times x to the positive 1/3. To the 0. Because what? 3x to the 1/3 times x to the positive 1/3. What? These, I get added, right? My bases are the same when I multiply. I add my exponents. Is that better? All right. Add my exponents. It's a hard lesson, but if you don't know your rules for exponents, you're really going to have some hard times on this. Okay? Emily, what was your question? Did you? Okay. All right. This one. Let's do a little side problem. If I have x plus y over 6, isn't that the same thing as saying x over 6 plus y over 6? Right? Okay. I can split my numerator and keep it over the same denominator. Would you agree? That's what we're going to do in this problem right here. Okay, because we're trying to simplify it out. We're going to take 9a to the 1/2 b to the 1/2 over 12ab to the negative 3/2 minus, what am I going to write for the next one? Over. Exactly. Now we're going to simplify each term. 9/12 reduces to what? 3/4. And a to the 1/2 over an a is an a to the, so we're going to put it down here, correct? Because if it's negative 1/2, it drops down to the denominator. Are you with me?
But wouldn't you, since that's the one on the bottom is a to the first, and the one on top is a to the 1/2, you're,
A to the 1/2 minus 1.
wouldn't you subtract the top one from the bottom one?
Yep. Right. I subtract the top one from the bottom one.
And it's still a positive 1/2.
No, this is negative 1/2, but it drops down and becomes positive when we flip it down here. You with me? Okay. B, what is my B going to be? It's going to be the 1/2 minus negative 3/2. What am I doing with the 1/2 and the 3/2? I'm adding them. It's minus my denominator, right? So that's B to the 4/2, which is 2, yes. And it stays up top because it's not negative. You following this? What is 1/2 minus negative 3/2?
So are we always supposed to, like, I'm just confused, are we always supposed to do the exponent, like adding and subtracting on the top, and then from there,
Mhm.
move it down?
Okay, next one. What does the fraction 6/12 reduce to? 1/2, 1/2. And I'm going to do a to the 2 minus 1, which is a. And where does the a go? What is 2 minus 1? Is it positive? Then it stays on top. Following that, Rachel? All right, on my b, what is b to the 1/2 minus negative 3/2? It's going to be b to the 4th, which is b squared. Stays on top still. Can you add fractions whose denominators are not the same? We separated our fractions and we simplified each of these terms. I cannot add these two together. That would be your final answer, yeah. Okay. All right, let's try this. So this is all about rationalizing your denominators. How do I know that I need to rationalize it? Because I gave it to you in root form. I didn't give it to you in fractional exponents. Do you understand that? So when they're in root form, you're going to have to rationalize your answer. All right? Now, if you notice under the roots in both of these cases, I got b's in both the numerator and the denominator and r's in both the numerator and the denominator, correct? So let's simplify that down. Under the 4th root, I'm going to have, the c has to stay down below. Would you agree? Because it has nothing to combine with. Where do I have more b's? On top or on the bottom? By how many? Okay. And my r's? By how many? All right. So now let's look. I need multiples of 4 for my exponents in my denominator, correct? I have 1c. How many c's am I missing down below? So we're going to multiply the top and the bottom by c cubed. We're rationalizing so that I don't have a square root in my denominator.
Why are you working with the c instead of the r?
I haven't done the r yet. I'm going to do the r next. I'm doing one variable at a time, Rachel. So how many r's are missing? So I'm going to multiply the top and the bottom by r squared over r squared. Would you agree? So in the numerator, I'm going to have b squared c cubed r squared. And in the denominator, I'm going to have c to the and r to the. But what is the 4th root of c to the 4th? And of r to the 4th? So do you see how they're no longer under the root? So my root is just in the top. B squared c cubed r squared.
Why did you multiply b squared?
Because I can have square roots in the numerator. So I don't worry about pulling anything out of my top. It's my bottom that I have to get rid of all my roots from. So who cares what's up at top? It's the bottom. Yeah, because the bottom is if we bottom, we don't want to have underneath the roots. Yes. All I'm doing is rationalizing, Pusha.
Oh, the CR is not under the.
Exactly.
I thought it's like C.
Over here, it still is. But I got now 4 of them and 4 of them, and so they're no longer under the root. That's why I don't have it extending past the numerator. Okay? All right, let's look at the next one. Under the 5th root, I have x to the 8, y to the 3rd, 2, z to the 7. Can I do any simplification in this problem first? Okay, hold on. I'm just meant, do I have any combining under my radical? No. Okay? And so then let's just worry about rationalizing our denominator. Okay? So how many 2's do I have? 1. How many do I need total? So I'm missing. I have 1. I need 5. How many am I missing? 2 to the 4th, 2 to the 4th. As long as I multiply top and bottom by that same value, I'm just changing the way it looks. Now, do I have to worry about my y's? Because it's on the top. Which one do I have to worry about now? The z's. I have 7. I need a multiple of 5. What's the closest multiple of 5? 10. So how many are missing? 3. Z to the 3rd over z to the 3rd.
When you say multiple, I think it has to be like 35. Because,
No, multiples of 5. 5, 10, 15, 20.
so you're adding them then?
Because isn't that what the rule is? When we multiply our bases, we add our exponents. Okay? Yes.
Why can't you just times with 10 plus like 5? And like 5z cubed and then get like 10z cubed on the bottom, and then here you take 10. Like,
Does 10 appear 5 times? Whatever you pull out, whatever number, whatever you pull out has to appear 5 times.
would it be like 2? That's 5.
No, we're multiplying, not adding. 2, 4, 6, 8, 10, fine when you're adding, but we're multiplying. Make sense? Got it? Yes, it is. All right, so up top, we're going to have an x to the 8, a y to the 3rd. 2 to the 4th is really what? Okay? We'll order this in a second. Z to the 3rd. In the bottom, everything should be coming out, correct? What? So I'm going to have, in terms of my 2's, how many groups am I pulling out? Just one group. So it's just going to be a 2, correct? And how many groups of z's do I have? 2, right? Because my exponent is 10, right? So I've got 2 groups of z's. Okay, now, let's reorder this still. 16, x to the 8, y to the 3rd, z to the 3rd, 2z squared. Is there anything that can still come out? Anything that's got an exponent underneath here that's greater than 5? The x has an exponent of 8, doesn't it? How many groups of 5's are in 8? 1. How many would be left under the root? 3. So this is going to be the 5th root, and we can pull out an x. 16, x to the 3rd, y to the 3rd, z to the 3rd, 2z squared.
Or the c squared.
Well, don't we have 10 of them? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 2 groups of z's, or 10 divided by 5. Yes?
So when you pull something out of the numerator, you just pull it out like for the x.
Uh-huh.
X, you pulled it out because there's 5 and you left the 3.
Yes. All right, you just lost an earring or something. I don't know, something went flying. Yes. Okay, do we understand that these z's came together and came out down here? Okay? This one's staying on top because it's positive, and the answer to that is 16. And 16 is 2 times 2 times 2 times 2. There's only 4 2's in there. So it's got to stay underneath the root because I'm looking for groups of 5 values to repeat. How we doing? Okay, I know, this is hard every year. All right, when we add fractions, what do we need to have? What's the denominator on my 3 right now? Okay. We can never just add anything to a denominator. If we're getting a common denominator, we must multiply. What should my common denominator be? X plus 1. So what do I multiply 1 by to get x plus 1? X plus 1 over x plus 1. You multiply numerator and denominator by that value. So that means I have 2 over x plus 1 plus what? 3x plus who? 3x plus 3 over x plus 1. So when our denominators are the same, what do? We add what? The numerator. So that's 2 plus 3x plus 3 over x plus 1, which is really 5 plus 3x over x plus 1. You can do 3x plus 5 as long as the sign's the same. Okay, next one. This is really a hard one to see. But do you see that this is a complex fraction? It's a numerator with another fraction down below. But these are on ACTs and SATs all the time. Okay? So, look to see what your lowest denominator is. Lowest meaning furthest down. What is the furthest denominator that you have? X. If we multiply everything, and I'm doing this as x over x. Well, hold on. We got to distribute. So when we take it to this numerator, would you agree that we get 2x plus x squared? And when we take this x to this first term, what does happen? The x's drop out, right? And what are you left with? Okay, what is 1x times x over 1? It's 1. So that term becomes 1. And no, because we got to take it to every term. What does that one become? Plus 4x. That's your simplest form.
I'm confused about how you picked x to be the
Because that was the furthest one down here, and that's what I'm wanting to get rid of. So if that's what has to leave, then if I multiply the top and the bottom by that value, I know that when I go to this first term in the denominator, Rachel, that denominator will drop out because it does this.
So it goes like x over 4, that you multiply the 4 and everything.
Exactly. Does that make sense? Okay. So if I gave you 2 plus x over 4 plus 4, then I would multiply by 4 over 4, right? So then I would get 8 plus 4x over x plus 16. The whole idea is to lose that lowest denominator.